Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello everyone and welcome to another exciting episode of IT Pro TV. I'm your host Vaughn Smith and we are going to be continuing on with our object-oriented Python series. And in this episode we're going to talk about, well, what exactly is object-oriented programming? And here to help us is Mr. Justin Dennison. Hello Justin.
Hi Vaughn, how are you today?
I'm great. I'm glad that you're here to help us define what we're going to be talking about overall and define some terms for us.
Well, Vaughn, I am excited to be back in the studio. This is a topic that we have to be careful with. You brought up a great question. What is object-oriented programming? And you know, sometimes I feel like I don't know myself. But in fact, we're going to hit on what is object-oriented programming. Particularly, it's a set of vocabulary. But it is also a thought process. Like, how do I approach these programming problems? And we won't have a lot of programming per se in this episode, but we will be thinking about programming. How do I design these systems? How do I build these systems? How do I follow these set of ideas to help us abstract a way to create these systems of software? Particularly in object-oriented programming, there are 4 principles. Now, this may vary depending on who you talk to. Some people add a 5th one, some people take away one, but there's kind of this root 4, and that is encapsulation, abstraction, inheritance, and polymorphism. So those are our 4 principles of object-oriented programming that we have to figure out, what do they mean? What's going on?
All right, so those sounds like some kind of complex words, so we're going to go through each one of them. So let's start with encapsulation. What are we talking about here?
So encapsulation, that's a weird, number one, that's a weird word. I think it doesn't roll off the tongue that well. But ultimately what it means is everything about an object. And what do I mean by an object? A thing. And actually, let's use some graphics here. So let's look at this nice little graphic I have to help us root this in. What is this, Vaughn? Do you know what this is?
That looks like an engine.
That is an engine. And encapsulation means that all of the inner workings, all of the data, all of the states kind of bundle together, right? An engine can be running or not running. And we don't think about it when we walk out to our cars in the morning, turn it on, and the engine fires. But there's all these things, all these changes that have occurred, and that is effectively encapsulation. I don't know how the engine comes on. I just know that it comes on when I turn the key. So that state, those methods, the implementation of how that works is hidden away from me. And when I turn on the engine, I actually end up, this is a hard one. This is a nice little wheel rolling down the road. My engine turns on and my car goes. So I don't know how that works, but it actually works. So encapsulation is the hiding of that state to where we don't have to worry about how it works. It just works. Now, along with that is the level of abstraction, right? So these are tied closely together. And what abstraction is in a technical sense is a consistent set of properties and behavior that are bundled together inside of an object. Now, let's take this object for a car, right? So, Vaughn, what would you say are some properties or attributes about this car?
Well, it's red. It has 2 wheels. It's got some windows.
So Vaughn has made a very accurate description, right? It's a red car. It's got a couple of wheels, some doors, and that's important because there's a lot more to this car if we really wanted to get into the nitty-gritty details, right? If I wanted to dig inside, well, is it a 5-speed or is it an automatic? Is it a 6-speed? Does it have all-wheel drive, 2-wheel drive, front-wheel drive? Does it have a full trunk space? Is the engine in the front or the rear? Is it a V8, a 4-cylinder? There's a lot of questions that can be asked. And what I find with abstraction, the whole purpose of abstraction is to pull away and look at only what you care about in the context, the set of interfaces. And what do I mean by interfaces? Like how you interact with it. Like how do I interact with a car? Well, I get in, I put my key in the ignition, I turn it on, and I drive it to work. And what's important in that context? The ability to get in the car, so the doors. The ability to turn it on, so the key and the fuel tank and the engine, those work, but those are hidden away from me. But at that moment, I don't care about what color it is. And that's what's important about abstraction. So if we look at it, if I'm designing a car, some car simulator, maybe the only pieces of information that I need about the car in that context are the number of wheels, what color is it, how many doors does it have, and if I'm building, let's say, either a simulator or maybe an inventory system, maybe that's all I need to know about the car. I don't need to know what is its top speed in those contexts. For the simulator I might, but for the inventory system I would not, right? So that's for a car. Let's look at a little different example. So Vaughn, do you have a lock to some portion of your house, or like a nice keepsake box or anything like that? Mm-hmm. So do you have a key to that?
Yes, I have a key on my key ring that I use, and I put it in the lock, and I turn it, and I go in my house.
So do you know how that lock actually works? Like how your key opens
No.
the lock? Yeah. Most people don't know, like, how does the lock work, right? Is it important in the context? No. I know I have a key. I know that I put the key in the slot, and I turn the key, and it comes unlocked. So that's the whole purpose of abstraction. That is tightly coupled with encapsulation, because just like the car, it's on or off. Or just like the lock, it's locked or unlocked, right? So we have that data hidden from us and how that's manipulated. But for abstraction, we only care about certain interfaces or properties that we care about. So those are tightly coupled, but kind of heady topics.
Yeah, I can see how they're very similar, like you're saying. And so encapsulation is this, it just turn it on and go. We don't need to know what's under the hood. We just turn the button on and we go along and everything's fine. And abstraction is where we're just picking out the pieces that we need when we need it, just within the context of what we're doing.
Right. And even that, we try to talk about this to convey the idea. That's still very heady, right? It's still kind of abstract, talking about abstraction. Wow, that was a meta comment. So 10,000-foot view, that's the important concept. Now, I tell you about these because it's hard to contextualize what is encapsulation and abstraction, but these will come up as we start building object-oriented projects using Python. So that's important.
Yeah, so these examples that we're going to be going through later in other episodes will really kind of drive home the points of these topics and these heady words that we're describing right now, and then we'll really kind of say, oh, okay, I get it now.
Yeah.
Okay.
So a little bit of vocabulary, and then we're going to go to implementation.
All right, great. So I heard another word in there with our 4 vocabulary words that we're going over, inheritance. Now, I'm thinking, is that like some money I'm going to be getting? Where are we going with this? Or is this like, where did I inherit my blue eyes, from my dad or my mom?
That's the first time I heard the word inheritance. I was like, oh, well, I'm redheaded. There's some redheaded genes in there. People give me, they're like, how do you have a red beard? That's kind of odd. So we are talking kind of like that. Now, I say it's kind of like that because we have to be careful when we think of biological inheritance, right? Passing traits along. Those are from 2 other sources, right? Your mom and your dad pass down a series of traits. And those traits can be physical traits, like how you look, but they can also be some things can be behavioral traits, right? How you behave, how you manage stress, things of those nature. In Python, that multiple inheritance is possible. But in object-oriented programming, typically what it means is I have some parent and it is passing down a trait. So you would look at only the traits that come from your dad, right, or from your mom, but not necessarily both, because that's not available in all programming languages. So in the context of object-oriented programming, we have to be careful of it's not a combination, it's just an actual pull down. And let's look at this in the context. Let's throw back to the lock. So if we take a look here, we have this lock, right? I have a key, I turn the key, it opens, that's great. This is a very generic lock. It has a set of properties. It is open or closed, or locked or unlocked. It has a key. It maybe has some other property, right? Its color is black, and that's it. It's very generic. However, this is a poor rendition of a combination lock, but notice that's a more specific type of lock. Anything that the combination lock is able to do, well, that is not always available in the standard lock, right? But anything that the standard lock is capable of, all of the traits, should be available in the combination lock. Is it locked or unlocked? well, yeah, the combination lock is locked or unlocked. Is that also a property of the standard lock? Sure, right? So we would say that a combination lock inherits those traits and behaviors from the lock. Now, I use a lock and not something biological because we have to think in terms of software systems, of design, and how do we think about these? What traits are common? What behaviors are common? And here's where it really gets interesting. People like to plan this out, and I like to plan as well, but sometimes you'll start to see these patterns emerge when we're actually programming and not just talking about these concepts. And then you can apply this idea during some code changes or what is called refactoring, where you take your current state of code and you move it around so it's a little bit cleaner, you don't have as much repetition. Because I could just say, these are two totally different things. I have a combination lock and a lock. But then someone goes, well, doesn't a combination lock and a lock, they're both locks, right? Well, yeah, and can't you open a combination lock just like you can a lock? Well, yeah. Well, since those are shared, in programming, we're able to utilize that to kind of not repeat ourselves throughout our code. And that's very important because it requires less work, and programmers are lazy.
So we're just pointing out, like in the combination lock, it's still a lock. We don't have to state that again. We're just saying what's new, what is different from this?
And that's a key point. What is different? What is new? What do I need to add to a lock to make it a combination lock, right? So a combination lock has a combination of numbers that you can put to unlock it. That is a new behavior. But everything else with the lock is still there.
So the combination, you spin it instead of clicking down with the actual hoop on top.
Right. So that's, you're catching on, Vaughn. It's making me happy. I do like it.
I think I'm getting all these terms, so I'm glad we're going on this.
All right.
All right, so I think we have another one that you said, and it sounded a little scary to me, honestly. I heard polymorphism. Okay, poly, multiples, but morphism. I'm thinking like some crazy sci-fi movie. I'm getting a little scared, so help me with this one.
So, Vaughn, polymorphism, I've always said that people like to use big words because it makes them feel good, right? If you just walk out into a crowd and just start saying, just say polymorphism, you might get some weird looks, but then there'll be someone to strike up a conversation, and it may be in a different context. So polymorphism, let's pull apart that word. Poly does mean many. Morphism means forms. And what that entails is, depending on the context, right, something may change. A behavior or a trait may change. So let's think about this. In a running shoe, right, you put on your running shoe and you start running. Now, I don't know about you, Vaughn. I still run very poorly in running shoes. But I would say if I were to put on ice skates and try to run, I'm still running. But the context of how I'm running has changed. And that means that behavior has changed. Not because something intrinsically about me has changed, but my environment has changed, or some kind of runtime change has occurred that has influenced how the running occurs. So polymorphism means depending on how things are going, how your environment's set up, or maybe it got hot or cold, or whatever it may be, the behavior or a set of properties may change to adapt. It's almost like adaptability. And we'll see more about this as we actually implement some polymorphic behaviors. So we've hit on these four ideas. Again, this is kind of a filler, right? A backload of these four ideas that are important when we talk about object-oriented programming. Now, keep in mind, I will highlight as Python, we're using this, but Python doesn't always abide by every rule. For instance, in encapsulation, the idea is to hide away data and implementation details from your users so they don't have to worry about it. It just works, right? You turn on the car, you unlock the lock. Python doesn't have a true private. There are ways to simulate it. There are ways to discourage people kind of poking around at the lock being unlocked or locked. But Python has no way of hiding information from people. So it doesn't truly have full encapsulation, but we will still abide by that principle because it helps with design. So we have these four pillars. Again, encapsulation, abstraction, inheritance, and polymorphism. And we're going to use these as a thought process, as a way to build systems, to think about systems as we go on into object-oriented programming.
Great. Well, I can see that this is a really important foundation that we need to know to be able to define these words that I feel you're going to be using them a lot, aren't you? So
Yeah.
we're going to be able to understand what he's talking about from a basic perspective and then see how this is going to actually play out when we get into that code and start actually using this.
Yep.
So great.
Yep.
Well, thank you so much, Justin, and I hope you all enjoyed that. And so signing off for IT Pro TV, I'm Vaughn Smith.
And I'm Justin Dennison.
See you next time.
Thank you for watching IT Pro TV.